So hi everyone, I'm Jay and today we are going to see the block diagram of interrupt for the microprocessor 8085. So this is the block diagram of interrupt. I know it looks a bit difficult, but trust me, it isn't. Now for the microprocessor 8085, there are 5 interrupts which are trap, RST 5.5, RST 6.5, RST 7.5 and INTR. Now these all interrupts are having priority. Like trap is having the highest priority. Trap is known as highest priority and the non-maskable interrupt. But the remaining interrupts are maskable. And the priority of the remaining interrupt after trap is RST 7.5, then after RST 6.5, then RST 5.5 and INTR. Now if we want to use any interrupt apart from trap, we have to use the interrupt enable flip-flop. You can see that in the interrupt enable flip-flop, the input is EI. So when we want to use the interrupt apart from trap, that is INTR, RST 5.5, RST 6.5 and RST 7.5, we have to set the interrupt enable flip-flop. So when EI bit is 1, the interrupt enable flip-flop will be set. The output of the interrupt enable flip-flop is given to the AND gates. We know that if any input of the AND gate is 0, we will get 0 in the output. And if all input in the AND gate is 1, in that case we will get 1 in the output. Now let's see the first interrupt, that is RST 7.5. The RST 7.5 interrupt is edge trigger. So whenever there is spike from low to high, this interrupt will be received. You can see that the RST 7.5 pin is connected to D flip-flop. So the question is, why this D flip-flop is necessary? Because the RST 7.5 interrupt is edge trigger, there is a highly chance that processor will miss that interrupt. Because in the fraction of time, if processor is not able to receive this interrupt will be lost. So that is the reason we have connected this RST 7.5 pin to the D flip-flop. So whenever there is a spike, this interrupt will be stored in the D flip-flop. You can see that there is a mask 7.5 pin. So if the RST 7.5 interrupt is not masked, the value of this pin will be 0. And when this interrupt is not masked, we are going to get the vector location for the RST 7.5 interrupt. So the question is, what is the meaning of the vector location? Vector location means whenever microprocessor receives any interrupt, processor will stop its current execution and it will jump to the vector location. So in this interrupt, when microprocessor receives the RST 7.5 interrupt, the microprocessor will stop its current execution and it will jump to the 003CH vector location. And from the 003CH vector location, there will be interrupt service routine. Now let's see the next interrupt, that is RST 6.5. The RST 6.5 interrupt is level trigger. It means in order to detect this interrupt, the signal at the RST 6.5 pin should be high for the particular amount of time. Then there is a M6.5. So if the value of the M6.5 bit is 1, in that case that interrupt is masked. If the value of the M6.5 bit is 0, it means this interrupt is unmasked. And when this interrupt is unmasked, the processor will provide the vector location. You can see that the vector location for the RST 6.5 interrupt is 0034H. The next interrupt is RST 5.5. Again RST 5.5 is level trigger. Level trigger means in order to detect this interrupt, the signal which is received at this particular pin should be high for the particular amount of time. And if this interrupt is not masked, the processor will provide the vector location. And the vector location for the RST 5.5 is 002CH. The next interrupt is trap. The trap is both level trigger and the edge trigger. So whenever any signal is received at the trap pin, processor will not check whether the interrupt enable flip-flop is set or not, and processor will also not check whether the trap is masked or not, because trap is non-maskable and highest priority interrupt. So whenever any signal is received at trap pin, processor will stop its current execution and it will jump to the vector location which is provided for the trap interrupt. So the vector location for the trap is 0024H. The last interrupt is INTR. Again, INTR is level trigger. And INTR is non-vector interrupt. Non-vector interrupt means for the INTR interrupt, the vector location is not fixed. User can provide any vector location they want, and that vector location can be provided using the RST instruction. You can see that for the INTR there are different vector location available, and from this different available vector location user can set any vector location. So when any interrupt is received at INTR pin, processor will stop its current execution and will jump to the vector location which is set by the user. And this is how the block diagram of the interrupt is done. And again, this is it for this session. If you still have any doubt, you can ask me in the comment section. Thank you so much.